Most people jump straight into building models, but that's one of the fastest ways to get wrong results. Before you predict anything, you need to understand what your data is actually saying. And that's where exploratory data analysis, EDA, comes in. It's not about fancy algorithms, it's about asking the right questions. What's really going on inside this data? Where are the patterns? Where are the problems? Skip this step and you're basically making decisions blind. Think about it like this. Imagine someone hands you a data set with thousands of rows. Sales, customers, prices, locations. If you immediately start modeling, you're assuming the data is clean, balanced, and meaningful. But in reality, there could be missing values, extreme outliers, hidden trends, or even errors that completely change your conclusions. EDA is the process of digging into that data, summarizing it, visualizing it, and understanding its structure before doing anything advanced. This idea isn't new. Statisticians like John Tukey were already pushing this concept decades ago. He introduced EDA as a way to let the data speak instead of forcing assumptions onto it. The goal was simple: explore first, conclude later. Because if you don't understand your data, even the most advanced analysis becomes meaningless. In practical terms, EDA involves things like checking distributions, identifying outliers, analyzing relationships between variables, and visualizing data using charts and graphs. You might discover that a small group of customers generates most of the revenue, or that sales spike during specific times, or that certain variables are strongly connected. These insights are powerful because they guide everything that comes next: what features to use, what models to build, and even what business decisions to make. But here's the part most people miss. EDA is not just technical, it's investigative. You're not just running charts, you're thinking like a detective. Why is this trend happening? Why are these values different? What's causing this pattern? The quality of your analysis depends on the quality of your questions. Two people can look at the same data, but the one who asks better questions will always find better insights. Now, with AI and automated tools, some parts of EDA can be done faster, but the thinking still can't be replaced. Tools can generate charts, but they can't understand context the way a human can. That's why EDA remains one of the most critical steps in data science. It's where raw data starts turning into real understanding. At the Learning Studio, the focus isn't just on teaching techniques, it's on building the mindset behind them. Because once you understand EDA, you stop treating data like numbers on a screen and start seeing it as a story waiting to be uncovered. And that's the point where analysis becomes insight, and insight becomes real value.